Can you guys see Apex on my screen?
Yeah.
Okay. So review. And you click on this, and it gives you a practice worksheet. So here's your feedback as a learner. If you can do the items on this review worksheet, and you can do the items on your study guides and your checkup worksheets in your lessons, and you got 90s or 100s on your quizzes in Apex, I would say that is all really good feedback for you that you are prepared to take the computer scored test. Okay, that's a good standard to follow. If your scores on your Apex quizzes are lower than 90 and 100%, I would strongly encourage you to contact me for a reset, and then you go through the lesson again, or get help from me on specific questions and then retake the quiz until you get a 90 or 100. Okay, feedback for you that you know the material at a high level. Okay, so you can see the worksheet on the screen. We're going to do this practice worksheet together to prepare for your Unit 5 test. You will need to do annotate if you would like to write on the screen. So go ahead and grab your pencil and annotate if you'd like to write. Claim a color by writing your name up there. Malachi likes that purple. All right, so Malachi is going to write on the screen. Katie, you're going to write on the screen today. Joseph, how do you want to participate today? Are you going to be taking notes on your own? Do you want to? Oh, awesome. You're going to be doing blue on the screen.
I could, but sometimes I'll take notes.
Awesome. Good. Okay, so here we go. Number 1 here. Use the graph to find the solution to the system of equations. So let's go ahead and do number 1. When we use the graph to find the solution, tell me again what we're looking for. What is the solution? I'll do red.
Where they intercept.
Where the lines intersect.
And what will the X and the Y coordinate that will solve both equations.
Beautiful. And so we're looking for ordered pairs. So when you guys identify your solution, really important that you substitute it into a coordinate pair form, X comma Y. So go ahead and identify the intersection and then write it as a coordinate pair. And those are your solutions. And we see a limitation with graphing. Sometimes it's hard to tell exactly where they intersect, right? Which is a reason why sometimes it's important for us to do the work algebraically to find the solution, because then we can find exact. So graphing, while you guys are writing in your solutions there, I still don't see any solutions written. All right, that first one is over 2 and up 1, 2, 3. So that first solution, does anybody agree with me? 2, 3?
I agree.
Beautiful. Awesome. All right, and number 2, to the left one, so it's -1. And to the left one and down 1.
The bottom one isn't exactly on there though.
It's not exactly, it's approximate. Okay. So about -1, -1. Okay. So graphing solutions is sometimes going to be approximate. Okay, important for us to keep that in mind. Finding algebraic solutions is always exact. And our 2 forms of algebraic solving are, algebraic's kind of a funny word. It might help for you to say it out loud. Algebraic. That means solving with algebra. Our algebraic solutions are substitution and what was our other form? You can yell it at me.
Elimination.
Elimination. It's hard for you to see the screen. Can you be more specific, Malachi? Tell me how I might adjust, or how is it different from other Zooms we've had, and I'll try and adjust. Okay. Oh, can I zoom in a little bit? Yes, absolutely. Okay, I'm gonna clear the screen. All right. Oops. Oh, I need to get out of annotate before I can do that. Aha, how's that? Is that better?
Yeah, thank you.
Ah, thank you so much for that feedback. All right, here we go. Let's look at number 3 here. So we want to solve this system of equations, and then we're going to solve it by graphing. And that way we should be able to verify that our algebraic solution and our graphic solution are the same. Okay, so I'm going to go back to annotate. Okay, so we're graphing these lines. We should be able to tell without graphing how many solutions this system has. So if we have 2 lines with the same slope, those lines will never intersect. Correct? They will have no solutions. What if we have 2 lines?
Unless they have
Go
the
ahead.
same y-intercept also, because that would mean they're on top of each other and they'd have infinitely many.
Beautiful. Infinite many. Okay. What about 2 lines that just have different slopes? They're increasing at different rates, even if they're going in the same direction, but at different
1.
steepnesses. 1. So how can we tell from our equations that we're going to have 1 solution? How can we tell? What do we look for? And in the equations, what do we look for? What did you just circle there?
I circled the slopes.
Good. So we look at slopes to know whether or not they're going to intersect. If the slopes are different, they will intersect exactly 1 time. Okay. Notice we have different slopes. One slope is 1/2. The other one is -1. I'm going to put in our invisible 1 there. Okay. Graph the system. Let's do for this top one, let's do pink. And the bottom one, orange. Ooh, those are pretty colors together. Okay, remind me, when we graph an equation, how do we start?
You can start with the y-intercept.
Okay, so to start graphing, you just know a point on the line. Find a point on the line. And because our lines are in slope-intercept form, we instantly know our y-intercept. So we know this is our y-intercept on that pink equation. So that's where we're going to start. So we know our graph. Good. Look at those beautiful y-intercepts. All right. Then we use a point on our line, or excuse me, a slope. Then we use the slope to find more points. To find more points. Oh my gosh, you guys have become master graphers. All right, and then what needs to go on both ends of our line? Oh my goodness, arrows to show where they that they keep going forever and ever and ever more, and circled the solution. You guys are a good team. Okay, so answer the question. You've made a beautiful graph here. We've graphed the system. We have not answered the question. Identify the solution. Always give that baby as a coordinate pair. Beautiful. 4, 1. You guys got it. Okay, questions on this one? Okay. Okay. This next one is interesting. It says approximate the solution to this system of equations based on the tables that were given of coordinate pairs. So first of all, do a quick check. We have two lines with different slopes. That means they're going to have one solution. They're going to intersect one time. All right. So how could we tell using our table of values? Notice we don't have a graph. How can we tell where our two lines are going to intersect? Does anybody have an idea they'd like to share?
Maybe the closest, the two solutions below the equations that are the closest to each other. Because if you place the x in the place, whatever, if you place one of the numbers in place of the x, that is what the y will equal. Like that.
Good.
If
So,
x equaled this, then y would equal this
good. So you're saying
in
that
this
is a
equation.
good. So you're saying the coordinate pair 1, 4 is on, and maybe we should put it in the table. Maybe that would help visualize it. So the point 1, 4 is on this line, y equals negative 2x plus 6. Where the point 1, 3 is on that other line. Good, good strategy. Let's look at the slopes. The first one is decreasing over time. Notice it's going down 2 each time, x increases. The bottom one is going up 4. So one is decreasing, one is increasing. What do you notice? Let's look at this top equation here, the first one. What do you notice about these x values? Or excuse me, as the x values increase, what do you notice about the y values? What are those y values doing?
They're also increasing.
Let's see. We go from 4, 3.8.
Some of them are decreasing though.
Good. So in that first equation, our y values are actually decreasing. All of them are.
Because the slope is negative.
Good. The slope is negative. So let's look and see what happens over here on the second equation. Our slope here is positive. What do you notice about our y values? Notice our y values are increasing. Okay, so here's kind of a visualization of what we have. We have a line that is decreasing over time. The y values are decreasing. And then we have another line where the y values increase over time. We are trying to figure out from a table where they intersect, where they cross paths. So let's look at our graph or our table. Can we tell from a table where the increase and the decrease cross each other? Katie says, I think it is this one. So you think they're going to intersect at about 1.2, Katie? So let's see what's happening at 1.1. Which one's above? The first equation, notice, is higher. Okay. And then at 1.2, notice the height has been overtaken by that second equation.
So it's about 1.2, 3.7.
Good. So the question is approximate where it will happen. So it's going to happen in between 1.1 and 1.2 for x. Okay. So x will be between 1.1 and 1.2. And tell me again what you approximated the y value to be, Katie. Cool, about 3.7. Okay, Can we identify a decimal value here for X that would be between 1.1 and 1.2? And then a Y value that would be between here 3.8 and 3.6. Oh, good. I like that. You've got 3.7. Cool. So about there. Whew. Cool. Okay. I'm going to toggle on the answer key and let's see how good we are. See how good mathematicians we are here. There you are, answer key. Let's see here. Let me get our, all right, how did we do? I'm gonna get rid of those drawings there. Did we do well? Did we match? Clear all drawings. Good. So we got it. We jived with theirs. Good. Good. So that was a challenging one. Now, if all else fails on that, you could graph it, right? And then see where they intersect. Okay, let's do some algebra. So let's look at, I'm going to turn that off. Let's look at some 5 and some 6 here, shall we? All right, you guys have your pencils sharpened. All right, so on number 5, we are using the substitution method to solve the system of equations. So reminder with substitution, you isolate one variable in one equation. So do we already have that in number 5?
We have one of them already isolated. So we
Beautiful.
should probably isolate the same one on the other equation.
Okay. Before we move to number 6, let's do 5 together, shall we? To get warmed up, since this one's easier. So we know y equals this. So we're going to substitute in then 2x plus 6 into the equation, the other equation. And then we're going to rewrite what we have here. So we have x plus 2 times our y value. I'm going to put our y value in parentheses because there's 2 terms in there. Equals 2. Why did my thing glitch? Okay, and then let's simplify. Sometimes the algebra can be tricky here. We want to distribute that 2 through. So x plus, we have 2 times 2x. So we have 2 groups of 2x. It's like we have a 2x and a 2x. So how many x's do we have all together? Beautiful. 4 x's. 2 times 6, 12, equals 2. All right, combine your like terms. All right, take it away. All right, and Joseph and Malachi, please ask questions, okay, on these. Like this time is for you guys to get questions answered. So if I'm going too fast or you want to talk about a step again, slow my roll, okay? This is your time. Okay, so we've combined like terms. Now we need to isolate that x value. Katie's doing a good job of showing all of her work. So now we're trying to get that x by itself. And once we do that, we will then know half of the solution. Beautiful. So x equals, beautiful. Okay, so we're halfway done. We know our x value equals -2. And so now we're looking for the corresponding y value that goes with that. Who can remind us how we find the corresponding y value if I know an x value?
You can substitute it
Into where?
into the one of the equations in place of x.
Good. And does it matter which equation we use, the top or the bottom one?
No, because they're equal in both equations.
Good. So we're looking for where they intersect. So we're looking for the point they have in common. So if they have the
I
same
would do it.
x, go ahead.
I would do it on the second equation because it has y isolated already.
Good. So typically we're going to find that one of our equations is easier to work with than the other. Okay, I agree with you, Katie. So I'm going to bring that second one down. So we have y equals 2x plus 6. If we substitute in -2 in there for x, we're going to have y equals 2 times -2, and then add 6, which is -4 plus 6. So y equals 2. So when x equals -2, y equals +2. Awesome. Okay, what questions do we have? Okay, so let's go ahead and do 6. First step for 6 is we need to isolate one of our variables in one of our equations. And I would say on this problem, there's 2 fast ways to do that. So Katie, what would you do if you were given this problem?
I would isolate one of the variables.
Which one? Do you have an idea of which one you'd go after?
I don't know. I would probably do it on the second one since the variables aren't attached to anything.
Oh, because there's no coefficient like that 2 there, that -2?
Yeah.
Okay.
I would
Good.
probably do x though, because on the top one, the y is attached to it.
Which then adds a step of complication later on, right?
Yeah.
So Katie's illustrating some patterns she's figured out by doing these problems so many times for practice. And that's the beauty of practice and fluency, is that you can then start to look ahead of the problem and see what could happen. Malachi or Joseph, do you guys have a strong leaning of which way you would like to solve this problem? Is there a variable you would like to solve for? And if we don't have any preference, then we can do Katie's method. Okay, so let's solve then the second equation. Let's get x by itself then. So subtracting y from both sides is going to leave us with x equals 1 minus y. Really important there. Your y value needs to be negative. Your 1 needs to be positive. So check your signs. Okay, now we know x equals this. So now we're going to take in that value and we're going to substitute it in for x into that top equation, the equation we haven't used yet. And then let's rewrite our equation. So we now have, I'm going to write the whole thing over here, x minus 2y equals 3. Okay, our x value though is 1 minus y, okay, minus 2y equals 3. Okay, there's nothing affecting my parentheses here with that 1 minus y, but I like to always write the original with parentheses just in case. So I'm going to drop my parentheses now and I'm going to combine like terms. Okay, so like terms here, we have a minus y and a minus 2y, which makes a minus 3y altogether. That 1 out in front is still a positive 1, has nothing to combine like terms with. So it's sad, but it's just going to hang out there by itself for a little bit. So our goal here is to keep getting y by itself. So the next step, now we're going to move that 1 over to the left side. See ya. And so we're left with negative 3y equals 3 minus 1 is a 2. Last step, divide both sides by negative 3. So y equals negative 2/3. Y equals negative 2/3. Okay. Thoughts on that? Feedback? When I get a final answer that is a fraction, sometimes that makes me nervous that I've done something wrong, okay? So we're gonna check the answer key real quick because we should be doing that anyways. But just know you're in the level of math now that just because you have a fraction answer key doesn't mean that you've done something wrong or a fractional answer. Oh, look at that, okay? I mean, I'm not surprised. So our y value equals negative 2/3. So yay. Okay. So I'm going to hide this answer key again, and I'm going to bring back that screen we were just doing. Okay. So we found the y value. Now we need to find the x value, or yeah, the x value, the corresponding x value. Okay. One of those equations is going to be easier to use than the other.
The second one.
I agree. So probably that bottom equation is the best one to use now to find our corresponding x value. Okay, so let's bring that down. X plus y equals 1. Let's see, our solution up here, we don't know our x value yet, but we know our y value is negative 2/3. Okay, so let's substitute in negative 2/3 in for y. X plus negative 2/3 equals negative 1/3. Oh, gosh, Miss Fergus. Equals what? Equals negative.
In the top, you wrote -1.
I wrote -1. Oh, yes, I did. And it should be a positive one. Thank you. Thank you. Awesome. Does that look better?
Yeah.
Okay. Geesh, thank you. I love it when students correct me. Okay. So let's add 2/3 to both sides. Okay. X equals 1 plus 2/3 equals 1 2/3. You could also write it just as an improper mixed fraction.
Like
of
5/3.
Or 5/3, good. Typically, you guys are to the age in math where the level in math that improper fractions are more desirable and more usable than mixed numbers, okay? Because think about slope. We want those as we want to see our rise and our run. A mixed number is confusing. All right, what questions do we have on this guy? Thank you for fixing my handwriting. Okay, let's do a quick check on this. Give me thumbs up, thumbs to the side, thumbs down with how you're feeling on substitution. Awesome, up, up. Okay. And if you're still to the side or down, practice is going to get you there. If you need help finding practice problems, I'm your woman. Okay, here we go. Let's see what else kind of trouble we can get into on this worksheet. Okay, let's do some elimination, shall we? Okay, 7, 8. Let me just look ahead real quick. I have another Zoom at 12 here that I need to. Oh, good. We're in good shape. Okay, let's do. I'm not going to do all of these elimination problems. Let's do. Which one looks scariest? Let's do the one that looks the most challenging of these, 7 through 10. Anybody have a thought? Otherwise, I can pick.
Number 9 looks the scariest.
Number 9 looks the scariest to Katie. Malachi or Joseph, do you guys have a preference?
Number 7 looks scary.
7 looks scary, very scary.
scary.
Yikes. Okay, we better do number 7 then. If we have time at the end, we can do 9 together. Now, keep in mind here, before you guys take your CST, you should be doing all of these problems, right? And then checking your answers with the answer keys. So this is, again, worksheet 5.5.1. Where are you? If you were my cursor, let's see. Okay, 551. Okay, so we're gonna do scary number 7 here. Okay, Joseph, what about this problem is scary? Because I agree with you, it is scary.
I choose it because it's the easiest.
Oh, Joseph. Okay, do you still want to do this one together, or would you rather use our time to do a different one?
I just want to get a quick review.
A quick review. Oh, good. Okay. So you think if you have a quick review of elimination that you can be, it'll help you?
Yes.
Okay, so let's do 7 here. Reminder, our goal with elimination is to eliminate, so to use addition or subtraction to eliminate one of the variables completely. And if we use addition here, what variable is going to cancel out? One of them will. If we add straight down, look at what happens to your y values.
The y one, the one that has both y's.
Beautiful. And one is positive and one is negative, right? So add them up, see ya, the y is gone. Okay, so then we're left with 8x. Oh, nice. You girls take it away. So 8x equals 8. Good. X equals 1. Now with all of these, our final answer is going to be written as a coordinate pair. Beautiful. Okay. So that one used addition to undo. Let's look at 8 real quick. We're not going to do it all together, but let's do the first step together. If I add straight down, do any variables disappear on number 8? 4x plus 4x would give us 8x. So notice our x doesn't disappear. But if we subtract it, it would. But here's the kicker. We have to subtract everything on the bottom. So I would strongly encourage you guys, when you are doing subtraction, that you actually rewrite the problem. I am a math teacher and I even go through this step because mentally it's too much to keep track of. So when I subtract that bottom equation, it's changing the sign of every single term. So notice every single term has 3 words, every single term. Make sure you're changing the term on every single term. And notice there's 3 terms. Hey, maybe that'll help you guys. Now notice when I add straight down, those x values will go away. Now check your y term there. What's 6y plus y?
7. Y.
7, good, 7y. So this one should be 7y.
Yeah, the subtraction sign on the equation though.
It is subtraction. So, oh, okay, you're right. I forgot to put in a sign. When we subtract, we're changing the sign of every single term. And then at that point, what we can do is then we can add straight down. So this negative means I have to change the sign of every single term in that bottom equation, and then we can add straight down. Does that clarify?
Yeah.
Okay, thank you for that. Keeping me honest. Beautiful. 7y equals 14. Okay, and we're off to the races there. Okay, That's a good start. Okay, I'm going to move us along. Joseph, how was that helpful? Was that a okay review? Get you started again.
Yeah, that refreshed it.
Good.
Now I know what to do.
Good. So expectation on this is that you do 9 and 10. Check your answers before you take the CST. Okay.
The coordinate pair was 3, 2.
Was 3, 2. Awesome. Thank you. Okay. You guys are a good team. You work really well together. Okay, let's look at number 11. So now we're getting into systems of inequalities. So this was when we had an entire half of a graph, and we want to know where the inequalities overlap, because that represents the solutions to the entire system of inequalities. So let's look at 11. The graph of the system, hold on, something weird, there we go. The graph of the system does not have an overlap region. So it would be something like this. Two linear equalities, notice they don't overlap. So the question is, how many solutions are there? So if it doesn't overlap, there's no solutions. Beautiful. Should have used different colors on that. There we go, pink. Okay. So let's go ahead and do 11B here. So same thing. Notice we have two inequalities with the boundary lines have the same slope, a slope of 1. And our overlap is between. So it's like this bottom line the shading is above it, and the pink line, the shading is below the pink line. And so the question is, where is the solution? Where is the double overlap? And that solution is like a long, skinny solution set. Good. So where the boundary overlaps is your solution. Beautiful. Okay, last one we're gonna do here. And I looked at your guys' scores on the quiz for the linear inequalities, and I was very impressed with what I saw on that quiz, which tells me you guys did a good job of making sure you were prepared before you hop to the quiz. You did your worksheets. All right, number 12, determine which set of inequalities is represented by the graph. So we have, let's do choice A, choice B, or choice C. Malachi instantly is going in for that point right there. Malachi, could you tell us why you zeroed in on that point on the graph?
It's the y-intercept, and the y-intercept is the last number in all the equations.
Good. It's a great first step to start with. And I'm noticing it doesn't help us in this case because all of our y-intercepts are 1. Womp womp. But a lot of times I have a feeling that would help us.
I crossed out the top one because the dotted lines are the ones that are not greater than or equal to.
Okay, so dotted lines means we're going to have just either less than or greater than. Good. So Katie took care of our other one. Beautiful. Okay, let's look at Let's call our orange, I'm trying to distinguish between there, orange and green there. The orange
I drew
graphs,
some
go ahead.
arrows.
Love
I
it.
drew some arrows because the one that is increasing is shaded below, and the one that is decreasing is shaded above.
Beautiful, good. So the question is, which line is which line? And so we can help determine it by looking at our slopes. So the orange has a slope of 1, and the green line has a slope of 3. So which one is steeper, 1 or 3?
3.
3 is steeper, and I circled those in green. So I'm gonna
I
darken
accidentally
in.
said one of them was decreasing, but both of them are increasing.
I know what you meant. You were talking about shading, right? Okay.
Yeah.
So there's our green line. Hey, McLean, I think he wants to go outside. Could you please open the door? All right, so green is our steeper line. And notice our shading is shaded above our green line. Above our green line. All right, and orange line is our less steep line. So I'm just gonna darken that in, beautiful. And the shading there is below that line. So which answer choice, B or C, is shading below the orange and above the green? So above means greater than, or is synonymous with greater than, and below is synonymous with less than. Good. So B is the correct one. So we're going to have less than X plus 1, meaning it's going to be shaded below it. So all of this is going to be the solution of the orange. Okay. And then greater than the green line, which is this one. And then our overlap, beautiful, is right here. There it is. Okay. So B is our correct answer choice. Okay. So Unit 5 test, take it only once you're done with your worksheet. Okay, you have a couple more problems to do on this worksheet. Also, if you have low quiz scores in Unit 5, text or email me, text me, I'll reset those for you. I would say if you have under 90% on any quiz scores, you go over that lesson again, do the checkup, check your answers, even a couple of them. Check your answers, get feedback that you know them correctly. Text me, I'll reset your quiz. You retake it, try to get a 90 or 100. Make sure you've got all those quizzes good before you take the CST. Okay, what questions do we have? And you have the entire week to finish your Unit 5 test. Okay, so there's no hurry to go and do it right now. The point is that you do your best work. So make sure you prepare ahead of time. Okay? Okay, if you don't have any questions, go ahead and go. Otherwise, stick around. I'm here.
Thank you.
And I'll see you guys next week.
Bye.
Bye. No, thanks.
Bye.
Hey, Malachi. Bye. See you later.